straight to what we're covering today. We're going to be looking at frequency tables and histograms, and we'll get them finished, and then we'll start the last section. I don't think I'm going to finish the last section, so what I'm doing is I'm going to cover as much as we can, and I've just removed it from this week's homework assignment. So, you know, if you haven't done all the work, it's kind of unfair to, you know, ask you to do the entire section. So that's been updated. We'll talk about that at the end as well, I think. So let's look at what we're going to do. Well, we're going to look at frequency tables, essentially grouped frequency tables, and we're going to look at class limits and what are called class widths, sometimes called bin widths. Bin like in a dustbin, like a thing you put things into. We've already talked a little bit about the shape, but not all of them. We're going to talk about unimodal and bimodal. We're going to talk about using salt to create histograms. And lastly, again, we've talked about it, we're doing a little bit more detail. We're going to do cumulative. So some of these take a lot of time. It's not that they're difficult, they're just laborious, right? You have a lot of things and they just take time. And so that's why I'm pretty sure I won't be able to finish the next section after that because of this. So I'll jump right in with the class limits and class intervals. So imagine that you have a set of data and it starts off with 15, 17, 21, 21, and it goes all the way to the end. And let's say the last number you've got is 57. And I've put them in order. And we have got to somehow put this into a frequency table. Its formal name would be a grouped frequency table. So if I counted, oh, let's say that there's 100 numbers here. So I have 100 data points from there to there, right? If I tried to do a normal frequency table, it just wouldn't work. So you imagine this is the ages of people. So you'd have age, and then you do frequency. Now, if you did a 1-for-1 deal, you'd have 15-year-old, 16-year-old, 17-year-old, 18-year-old, 19, 20, and 21, and so on, right? You'd finish it way down here at 57. Can you imagine how tall that table would be? Wouldn't it be really big? Right? 15 all the way down to 57. What's that? About 40 odd numbers, 42 numbers. And I then do the frequency. Well, there's one of these. There aren't any 16s. There's one 17. There aren't any 18s, aren't any 19s, aren't any 20s, and there's two 21s. Can you see that the table would consist of very small frequencies? Wouldn't it be zeros because there isn't one? You might get a really lucky 4 32s, right? But you won't get many of them. And by the time you're finished, wouldn't that table be just as useless as me just telling you what the 100 numbers are? Right? You wouldn't really be able to get a lot of information, which is why we need to do grouped frequency tables. So you still have age, but it'll be a group of people, and you'll still have frequency, but it'll work more like this. So how many rows do you want in your table? It's very important, because that's going to decide these guys. It's going to decide what is called, its fancy name is, it's going to be called the class interval. Now, there are rules about the intervals, right? They have to be the same size. You can't have, you know, 10 to 15 and then 16 to 40, you know, and you make them all different sizes, right? They should all be equal widths, right? So we're going to figure out how many classes that we've got. Classes is how many of these fellas you want. And sometimes the book will tell you, and they will tell you that they want 7 class intervals, or they want 4 class intervals, right? Or something like that. So let's suppose I want 7 class intervals. then we're going to use this guy to figure out first what the class width is. And it's the largest number, which is 57. Take away the smallest number, which is 15. And then you divide by the desired number of classes. Since I want 7, I'll divide that by 7. So on my calculator, I'm going to find out how wide, how big, I guess you could say, each of my intervals is going to be. So little bracket, 57, take away 15, all divided by 7. And by sheer luck, not planned, I got the answer 6. Can you imagine that most of the time you're going to get 5.91 and 6.32, right? You're going to get decimals. So what you do is you round it off to the nearest number. So in this case, it's exactly 6. That is great. So what you now do is you look at your data. We've got it, right? You look at your data and you start your interval at the first number. And you are going to have 6 numbers in each class. Now, watch this sneaky thing. You might say, that's dead easy. Add 6 to that and you get 21, right? So you would say, my first interval would be all the numbers from 15 to 21. Look, there's 6 numbers in that interval, right? Well, let's count them. 15, 16, 17, 18, 19, 20, 21. Wait a minute, that comes to 7 numbers. Class width says you must have 6 numbers in each interval. Do you notice that? So my interval should only be 15 to 20. Let's check that out. 15, 16, 17, 18, 19, 20. Would you agree there's 6 numbers in that group? So your first interval is 15 to 20. You then start with the next number, 21. What would my next group be? 21 to what?
26.
And if you count them with your fingers, that works. The next group starts at 27. Where will it finish? There is a pattern if you look at the columns. Where would it finish?
33.
Let's check it. Is it 33 or 32?
32.
32. Now, the pattern I'm talking about, do you notice that the first numbers go up in 6s? And you know that the end of the interval also goes up in 6s? So actually, once you've got the first interval, can't you just use the class width and keep adding all the way down? So the next number would be add 6 and add 6. Then it would be add 6 and add 6. Then it would be add 6 and add 6. And then it would be add 6 and add 6. Have you noticed that the last interval contains my biggest number? In this particular case, it's 57. And then what you would do is you would count all the numbers from 15 to 20, right? And in my case here, I can actually see those guys, it's 2. Can you imagine that the next one was 18, and the next number was 30, then it was 10, so 20, 34, 50, 60, 70, 85, there. That's what your grouped frequency table would look like. What essentially you would do is you go through all of these numbers, right? And you count how many of them were 15 to 20, right? And then you'd count, in this case, it'd be 2 of them, right? And then you'd count all the 21s to 26s. And then after that, all the numbers that were 27 to 32 until you got finished. Does that make sense? That's how you approach it. Now, I was told to do 7 class intervals. Let's suppose they told me that they wanted 10 class intervals. Well, if you're doing 10 class intervals, that means you're going to have 10 of these guys, right? Each one of these is called a class interval, so you want 10 of them. So we are going to be looking at first finding the class width, and that is still the biggest, take away still the smallest, but now divided by 10. And let's see what kind of number we get here. 57, take away 15, divided by 10. And the answer I get here is 4.2. Now that needs to be rounded off, right? Because you need 3 numbers in a group, 7 numbers in a group, 5 numbers in a group, right? You can't have 4.2 numbers in a group, right? Doesn't make sense. So what we would do here is I would reduce that and call it 4. Now, you then would do age and frequency, and we'd start at 15. So that's my first one. And the first one is always the tricky one, right? If you figure out what the first one is, you can use a pattern for the rest. I want 4 numbers in this interval, right? I'm starting with 15, 15, 16, 17, 18. Do you notice if you subtract them and add 1, you should get 4? If you subtract these and add 1, shouldn't you get 6? Have you noticed that little pattern? That when you subtract the beginning and the end of an interval and add 1 more, that's how many numbers there are in the interval, right? That makes sense? Right. So the next number would start at 19, basically go up in 4s, and then 22, go up in 4s. Go out of sync there, 50, 54, and then 58, right? And then these go up in 4s. There. And let's check. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Oh, there are 11 intervals. And we were asked to create 10 intervals. And you might think, well, we've screwed up, right? You know, we're wrong. No, you're not really wrong. 10's not fixed. What that just means is we'd like 10, but if you end up with 9 or 11, we'll live with it. Doesn't it depend on how this number rounds off, right? So you might end up with 9 intervals. You might end up with 11. You could tweak it if you like, but we don't care, right? 10 is like a goal, but you can be one out either side, and it's still okay. Now here's a different question. Have you noticed that my intervals go 15 to 18, and then the next one goes 19 to 22, right? Why can't I do 15 to 18 and then 18 to, I don't know, 22 or something, right? Whatever. What is wrong with this interval?
You're counting the same number again.
Yeah. And there's a homework question that asks exactly that. It says, hey guys, suppose I use these intervals. What's wrong with it? And you will say, you're counting the same number twice. I call that double dipping, right? You're double dipping here, right? You're counting 18 in one group and you're counting in the second. You see, that's not really a good way to do things. Now, suppose I had this group set up and I happen to have in my data set actually a 58. That would work, agreed? You could get 58. But suppose I also had a 59. If this was my entire table, wouldn't it not work? Because I've got one guy missing. Right? 59 doesn't fit. I'd have to put another interval, wouldn't I, to be able to get 59 in. So I think there's a question that says, what's wrong with this grouping? And you're going to say, hey guys, one of my numbers doesn't fit in the table, right? You haven't given me a place to put it. And that would be bad news as well. So don't double dip and don't miss anybody. If there's a 59, your interval has to go to the place where 59 is. For instance, wouldn't this table be a bad table if there was a 13 in my data? Suppose one of my data points was 13. Wouldn't this table not work? I wouldn't be able to put it into my information. Any questions so far? Okay, so let me show you examples of what I was talking about. Okay, I don't know if I'll try and make it bigger, but then we end up missing. Oh, good, got one. A data set has values ranging from as low as 10 to as high as 52. What is wrong with this group of intervals? And darn it, the answer's there. We don't want to see the answer. So hopefully you didn't have time to remember what the answer was. Right, here we go. What is wrong with just using those intervals on data that starts at 10 and finishes at 52? Why can't I use these intervals? What's wrong? Okay, the biggest number is 52, isn't it? Is there any place for 52 to live in that table? That's what's wrong with it. So figure out which one of those four sentences mean the same thing. Now, here is a different set of data. And the smallest number is 10 and the biggest number is 50. But what's wrong with those intervals?
Double dipping.
Double dipping. So figure out which one of these is the more lawyer way of saying double dipping. So what we're going to do now is kind of go through that process that I just did in paper and show you how you do it. With a real question. So a data set with numbers that start at 20 and finish at 82. Find the class width, right? So first thing I'm going to do is I'm going to find how big each of the intervals is, right? The class interval. So it's going to be 82, which is the biggest number. I'm going to take away 20, and they want me to have 7. See that? 7 classes. So I'm going to divide that by 7. And on my calculator, 62 divided by 7, it comes out as 8.859. Right? 8.85 roughly, right? What do we round that off to? Because we need a whole number for these intervals. Agreed, 9. Now, start with the first class, right? That's basically, this is the way that you're going to write these intervals down. Right, now, I know the smallest number is 20. Now, the interval is going to have 9 numbers in it. If you can get the first one right, the rest is easy. 20 to 20 what will have 9 numbers in it. And it's not 29.
28.
It's 28. Isn't it what you thought it should be, take away 1? I guess that's one way of remembering it, right? Now, won't the next group start at 29? Great. And what will it finish at?
37.
Correct. Isn't it easier to use the numbers above from now on? So 20, 29, 38, 47, 56, 65, 74. Are you comfortable about, once I know this one, you can just add 9s, right? So you don't need to keep taking one away all the time. Now, if you start at this one and you add 9s, you're going to get 46, 55, 64, 73, I believe 82. And do you see? Everybody fits. And that's a sign that I know I've done it right. Now, there's a bit missing here, and that's good because it takes forever in a day. But can you imagine that they actually gave you a big list of numbers, right? Then there'd be another column here called frequency, and you would scan through all your numbers and say there was 5 numbers that were between 20 and 28. There were 9 numbers between 29 and 37. Can you imagine how boring that's going to be, right? But you would add them all up and stick them in, and that would be a completed frequency table. Are we comfortable now that if I tell you I want 7 intervals or 10 intervals, that you know how to calculate how big the interval should be, and then start with the small one and just work from there? Are you comfortable with that idea? It's a little bit time consuming, but I don't think it's hard. It's just blinking laborious. Right. Now I'm going to return back to the notes, and I'm going to add to yesterday's descriptions of what histograms can look like. Well, we know symmetric, skewed right, skewed left, and we've also talked about outliers. But here's another 2 terms, unimodal and bimodal. If you kind of draw kind of curve, for me curves looks easier to see what's going on. Would you agree that this shape is skewed to the right? You agree? Skewed to the right. It has one hill. And one hill, any histogram with only one obvious hill is called unimodal. Uni like in unicycle. Uni means one off. One hill, one mode. Of course, data comes in all shapes and sizes. This shape is not skewed to the right or skewed to the left or symmetric, right? None of those terms work for it. But it does have 2 hills. One of them just is taller than the other, but that doesn't matter. Would you agree it's got 2 distinct, obvious hills? And those are called bimodal. So if you have a histogram that contains 2 clear, distinct hills, not just little wobbles up and down, but really noticeable hills, we call it bimodal. So unimodal, unicycle, 1 hill, bimodal, bicycle, 2 wheels. Now you could do, but they don't do this typically. You could have data that look like this. Imagine that could happen. This shape has got 3 hills, 2 big ones and a little baby one, right? What could you call a histogram that looked like that guy?
Trimodal.
Say that word again.
Trimodal.
Correct. But we don't. We just call them multimodal. So if you've got 3, 4, or 52 hills, we don't care. By the time you're by 2, we just say it's multimodal, right? We don't need to specifically say how many hills it's got. It's just got more than 2, right? In fact, that kind of makes sense. Can you imagine if the data is really big? There might be 4 hills, but one of them is a little bump, and should I call it a hill or not? You know, there's kind of arguments about it. So see, if you just say it's multimodal, won't it work no matter if it's got 4 hills or 5 hills? It's still going to be called multimodal. Now, data does come out in a multimodal way and in a bimodal way. Bimodal, for instance, can very often happen, being sexist here, but it's still true. If you measure data and you're measuring it and it's women and men, you might find, making this up, but males, females, because females, being sexist, but it's true, aren't males in general taller than females, on average. A lot of women are taller than me, but on average, aren't they? Can you imagine what a histogram might look like? Double bump. I'm trying to think of other examples. They're quite common, right? You can have situations where essentially what you're looking at is not one population, but 2 populations interacting with each other, right? And so when you see a bimodal shape, it's normally a good clue that your data is made up of 2 distinct groups that maybe you should look at in more detail and separate. Are we cool with the added names? Unimodal, bimodal? And we already should hopefully remember the stuff to do with symmetric and so on. And now we're going to do those questions which I dislike the most, but we need to do them. And I think the reason I dislike them the most is because I keep arguing with the book, but you know, they're the guys that pick the right answer, so we have to choose them. You are a manager of a try that again. You're a manager of a specialty coffee shop. Do you pronounce it specialty?
Specialty.
Yeah, Americans don't talk right. Okay, it's a specialty. My wife says I pronounce all the syllables, right? Which I probably do, but we would call it a specialty, right? So there's a special coffee shop, how about that? And they collect data throughout the day regarding the waiting time for their customers. And you can do that quite innocuously. Couldn't you just have a camera and somebody later on in the day, you know, looks and says, okay, a little counter, how long did that person wait, and so on. Now, obviously, you want that to be small, don't you? You're going to lose customers if you have to wait half an hour. Most places will lose customers if you have to wait half an hour right before you get served. So what type of distribution do you think, oh, that moved for no reason. What kind of distribution do you think would be most desirable for the waiting times? So would you like it to be skewed left, skewed right? Oh, another name for symmetric, mound-shaped. I missed that one. I told you, didn't I tell you yesterday, bell-shaped, symmetric, and normal? Well, evidently there's another one called mound-shaped, right? So, which of those would you like in a coffee shop situation? Skewed left, skewed right, or symmetric? Coffee shop, what do you think they would want to be true? Last chance.
Skewed left.
Skewed, definitely. So let's draw a picture and see what that might look like. So along the bottom, you've got how long a particular customer waited, right? So this is the time it took that person from walking in the door to getting his coffee, right? And then up here is the frequency of that happening. Here is a skewed right. What would that tell me? Well, wouldn't it tell me that the vast majority of people got served really quickly, and only a few unfortunate people during the rush hour had to wait any significant amount of time? Would you agree that would be a good shape for the coffee company, right? What would be the conclusion if it was actually skewed left? That is not a coffee company I want to go in and get a coffee if I ever drank the stuff. Wouldn't there be very few people who get served quickly, right? That's, I don't know, 5 minutes, right? And let's suppose that's 25 minutes and that's 30 minutes. Wouldn't there be huge chunks of people, right, waiting an awful long time before they get served? Wouldn't that be the worst case scenario for a coffee company, right? Very few people get served quickly. A lot of people have to wait a long time. This is good. A lot of people get served quickly and only a few get served like that.
And I said it, I imagined the top one, but I said the bottom one.
Oh, so you knew the picture, you just gave it the wrong name. That's easy done. Try and remember where the tail goes. That's how I remember. If the tail is to the right, it's right skewed. And if the tail is to the left, it's left skewed. That's how I kind of remember. Here is a particular distribution, and it's going to be bimodal. Anybody get any idea how that could happen?
Maybe like rush hour times or
Yeah.
busy moments.
If any of you have worked in a restaurant, which I haven't, but I have spoken to people, don't you have busy times and you have quiet times? And so this bump here must have been, I don't know, lunchtime when everybody wants a coffee, right? And so a bimodal situation might have happened. So that might have been what you did get. And they go into, in this question, and talk about a bimodal, and they give you some sentences that you try and make sense of. So moving on to our next question, question 9. Let's look at this histogram, and basically what we've got here is a histogram with group data. If you want to know what the intervals are, it's 8.5 to 12.5 and 12.5 to 16.5. Now that sounds like a contradiction, so let me tell you how you do these intervals. If your car takes between 8.5 to 12.5 miles to gallon, it belongs in this rectangle. And there were 6 cars with that mileage. So 8.5 up to and including 12.5. Now the next group is bigger than 12.5 up to and including 16.5. So that 12.5 isn't double dipped. You give it to the smaller interval that came before. So this interval here, right, 12.5 belongs to. In the second interval, 12.5 isn't counted. It's the one just above it. Like I got 12.51 miles per gallon, right? Then you get counted in the second group. But all the way up to and including 16.5. So that's how they kind of do these groups. Let me write that down. I think if you see it, it's maybe easier than hearing it. If I said to you that it was going to be 10.1 to 10.4, and then the next group was 10.4 to 10.5, And then the next group was, that been before, that'd be 3, so that'd be 7. Then it's 10.7 and up to 11.0. The way you read these groups, and this is what you do when the data is continuous, right? When it's people, you can only have 4 people or 5 people, right? But see if it's the weight of something, can't you have 15.1, 15.2, 15.111, right? You can have that. So when the data is continuous, you have to feature this in. So this would be anything that weighs 10.1 pounds up to and including 10.4 pounds. So that's what that group would be. This group, however, would be anything that's more than 10.4 up to and including, that's many say 10.7. Do you see how it works then? So you're not double dipping. The number that's in the middle between one histogram and the next gets given to the group left, right? So if that number happens to be your car's miles per gallon, you belong in the left-hand rectangle. So let's return back to that question. Is it bimodal or unimodal?
Bimodal?
Yeah. Would you agree there's 2 distinct, what do they call them, peaks? I call them hills. Yeah. Now, this was data on how many miles per gallon older cars are, right? So somebody's got a really good car. Look at that car, 36.5 to, well, more than 36.5 up to 40.5. One car got that. That's a really cool car if you could get that. Josie looked at the raw data, right, the original numbers, and discovered that 54 data point values included both the city and the highway mileage. So the data was actually 2 numbers. You know, if you drive your car in the motorway, you get much more miles per gallon than if you drive it in the city. And this data had both those numbers in the list. And that's what was causing the bimodal. Isn't there essentially 2 different sets of data? What my car gets on the motorway, and then what my car gets when I'm driving in town. Right, so that data had them both in the data set, right? Both numbers were in there, right? So he separated them out. And this is what the histogram looks like when you drive your car in the city. Now, when you look at that, we agree that is definitely unimodal now. I'm pushing it, but I'm going to ask it. Do you think it's skewed right, or there's enough of it to maybe say it's skewed right? Or do you think, nah, I wouldn't call it skewed right? Because that's kind of judgment call, isn't it? There's no right or wrong answer. What do you think? Do you think it's skewed right or not?
I'd say skewed right just because there's 1 data point on the left of the hump and 2 data points to the right.
Yeah, I think that would be a reasonable answer. And if someone said, nah, it's only 1 car, if you took that car out, wouldn't you just have 3 rectangles and it would be, you know, uniform? And that would also be correct. You see what I mean by judgment call? It's not that it's a right or a wrong sometimes. If the data is not clear, you sometimes have to, you know, do your own thing. Now, what we're going to do now, or at least start to do now, is take the data that you can see here and use it to create one of these frequency tables. So use this information for the histogram shown above. Construct a frequency for a highway mileage of the same cars. So when they're saying above, I originally thought they meant this one, but I believe they actually moved this one. So let's check. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6. Oh. Oh, I don't care. They tell me what the boundaries are. 16.5, 20.5, 20.5, 24.5, 24.5, 28.5, 28.5.
I thought you couldn't overlap numbers.
Ah, well, I'll come to that. You are allowed when the data is continuous. Remember that up to, but not including thing that we talked about? That's what's happening here. So once I finish doing this, I'll say that again. 32.5. So when your data is discrete, right? 4, 5, 6, 7, right? Where your data can only be whole numbers, right? Discrete. Then you're not allowed to do the overlap. But if your data is continuous, like height, weight, miles per gallon, stuff like that, you are in need to kind of do, it looks like an overlap, but we have a way to not have a double dip. So where am I? 36.5. God, it just takes forever. It's not, as I said earlier, that difficult to do. At least that part is. Now, let's suppose someone's car was exactly 24.5 miles per gallon. I either include it in this group or that group, but I'm not allowed to double dip, right? I can't count it in both groups. And the way that you do this, the convention is that when you see an interval like this, you will read it as 24.5, starting at 20.5, but not including it, all the way up to 24.5. So you only include the bigger value in your interval. So 24.5 gets counted here. 32.5 gets counted here. If you were 36.5, would you count it in this interval or would you count it in that one? Which one would you count 36.5 in?
In both?
Not allowed to count them in both. So which one do you choose? The 32.5 to 36.5 or the 36.5 to 40.5?
32.5 to 36.5 because the 36.5 is the little tiny fraction after.
Okay. Now, the numbers that we are going to get from these wait a minute. There's something wrong here. There is something wrong here, guys. Now it says use information from the histogram shown above, construct a frequency for the mileage cars using this value. Now, the interval they've gave me is 16.5. But I'm looking at this data. Isn't there 8.5s and 12.5s going on? I wonder if that's a mistake. Let me put in the key and see what the problem is. Oops. Okay. 16.5 to 20.5, right? You know my intervals are correct, right? You see the match. And they say there's 2 in it. So let's see it. 16.5 to 20.5, there should only be 2 numbers. Okay, I need help here. Where is that 2 coming from? Normally I argue about the sentences. It's very rare for me to argue about the numbers. I mean, if you look at this interval, isn't there 7 numbers here? Right? So if I was doing a 16.5 to the 20 anything, shouldn't that number at least be 7 or more? You see what my problem is? Now, if I use this one here, if you do 16.5 to 20.5, would you agree that this is 5? Which also isn't that guy.
Wait,
I'm getting really annoyed at this question. Is there something that I'm just being dumb about?
wait, try starting at 40.5, because maybe it's cumulative, the opposite.
Right, see, I'm trying to get what you're saying. Where am I going to get the numbers for? Do you think I'm getting it from this one? Or do you think I'm getting it from this one? Oh, I can tell you how 5, 8, 27. I know now they're getting it from here because there's 27 numbers here and that's got a lot more than 27. Okay, so allegedly this table here generated these numbers. Anyone got any idea how that's 2? How did this table, this histogram, get me 2 when you start here and you finish there? Right, I'm not wasting any more time. There's something weird going on. I'm going to kill question 9 because I don't know what the answer is, or the alternate would be, can you just remember 2, 3, 3, 12, 6, and 1, and we'll argue about why those numbers are them, because I do not see at all where they're coming from. I may be being slow today, which I am, but there's no obvious way that those numbers are coming from that 27. I mean, just look at that. From 16 to 20.5 is 26 numbers. Right. So remember 2, 3, 3, 12, 6, and 1, and call it good. And if someone figures it out over the weekend and says, oh, you did this to that, and that's where they came from, I'd love to hear from you. But right now, nothing makes sense to me in that question. Now, I can live with data that's already given to me, right? I can tell where the answer's coming from, right? Because I got them in front of me. So this is our next question. Here is a set of data starting at 54 and finishing at 280. And it says here, make a histogram. So we're going to do that histogram again, and it's going to have an outlier and so on. And the boundaries are actually given to us here. So if you look at this interval here, 53.5, 99.5, and so on, I should just be able to hit set. Oh, let's check. 1, 2, 5. Okay. So we'll go in here. There's our data. Go to charts and graphs. Tell it's a histogram. Pick the salary. And now we need to, oops. Can I get that question back? Let me see. Yeah, I can. Right, it starts at 54. So that's good. And the class width, right, if you take this number and subtract that number from it, we'll get our class width. So let's see, 99.5, take away the start number, which is in this case 53.5, and we get 46. So back here, make that 46 and recalculate and shrink it so we can see the damn thing. Right, maybe shrink it even more. Remember, it might be this question. If it wasn't, it was one just like it. Can you see that as histograms go, that is a pretty useless histogram? There's virtually no information. Do you notice that there's a guy down here, one observation? Would you agree that that's an outlier? It's an extremely large value. So what we're going to do now is we're going to go back to our data set, and they get us to look at that number. Would you agree 280 miles away from the next number? And let's just bin it. It's gone. And then I'll go back to charts and graphs. And I'll change this guy to, what was it? Well, how many do we want? Let's say I want 7. So if I do 7 there, recalculate it. There, much nicer looking histogram. So their question, oh, let's get the answers out of the way. Their question started off with, here, which one of these guys was your problem? Right, and the guy we got looked like him. Now, is there definitely an outlier? I would say yes. Probably the owner. If you take out the 280, but you do this now. Okay, now when I look at that, there's 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. So I'm going to go back to my guy, and I went and made that 7. But really, I should probably make it 9. There we go. That's good. Let's try 8. I want 6 if I can get away with it. Yeah, that looks good. And one of the guys I just drew looks like this guy. And, oh, there's 5 intervals. They want 5 intervals, okay. Then I'll just take this guy and make him 10. I want to see 5 rectangles. There we go. 1, 2, 3, 4, 5. Right. So imagine that shape. One of these guys should look like him. What did they start with? 53.5? Okay. And I think I've rubbed the damn thing out. I've lost it. I think it was that one. But don't quote me on that. Okay. Here we go. Using SALT again. A whole load of data. And it's a percentage male enrolled in co-ed universities and colleges. This is interesting data. I'm going to do that question in a minute, but since this is kind of interesting to me at least. This 34 means in that particular university or college, so co-ed means males and females, because I think in America, aren't there still some universities where only females go to? There's probably a few, not many, but there probably is. There might be some universities, I can't think of one, where only males are allowed to go to. But most universities, colleges are co-ed. That particular one is 34%. And this one here is 53, and this one here is 35. Now, although I haven't put the data together yet, and there's a whole load of things going to go here shortly. What that data is telling me something, and that is, have you noticed how small, in general, the percentage of males who go to college? Now, that is a phenomenon that has really only occurred over the last 40 years. If you went back to America, say 50 years ago, there'd be much more males at university than females. much more males at university or community college than females. But today that has changed. Olympic College, do you know what percentage of males to females there are at Olympic College? Do you think it's even, or do you think there's more females? There are more females at Olympic College. So, interesting phenomena. Do you think we should have a program to try and get males to go to higher education? I mean, that's what we would do when it was the other way around, didn't we? If there wasn't enough Scottish people going to university, wouldn't there be a program to try and encourage us to go? Interesting. So, side issue, nothing to do with what we're dealing with. Let's find the class width, and they want 5 classes. So that's big, take away small, divided by 5. So let's get that guy sorted out first. God, that's hard for my brain. Can you scan through that? I can see a 61. Can anybody see any unit?
In the top row?
Oh, a 71. Oops. So that is definitely not following what I just said, but that's one data point. Aren't there a lot of 40s and 30s in there as well, right? What's the smallest? I can see a 34. Anybody got less? 31 now. Anybody see a 20, anything?
I don't see 20 anything. I think 31's
There's
the
a
lowest.
29.
There is. I'm sure you're right. Oh, there it is. 29.
There's a 24 in the 3rd row.
Oh, God in Himmel. Right. Is my last bid 24? Right. Can
Yeah,
you see how easy it is to screw that up? Right. But we've got them. Big take away small. And I want 5 groups. And that is going to come out as probably a decimal, and that's okay if it is. And so if you wait slightly patiently, I've got 9.4. So round that off to 9. I guess I could round it off to 10, couldn't I? Because 10's a nice number, but 9.4 is the best. So it's going to be 9. Now, the smallest number we found is where the class limits go. So you're going to, this is, oh, by the way, have you noticed that this is discrete data again, right? It's 42, it's 43, right? Nothing in between here. So we could do a class limit with whole numbers, or we could, I'll show you a different way of doing the same thing in a minute. Right, class limit. What was the smallest number we found? 29? Okay, 29 to, right, 29, 30, 31, 32, 33, 34, 35, 36, 37. 29 to 37. Okay. So we would be doing 29 to 37. And then add 9 to that, which would be 38 to, what, 46. I find it easier to go down columns. I don't know why, but I do. So that one would be 47. That one would be 56. And that one would be 65. And then this one would be 55, 64, and finally finish with the 73. Right. Are you comfortable with those numbers? Now, does the last interval contain the biggest answer, which I believe is 71? Yes, it does. So that's a good sign we're on the right roads, right? 5 groups. Now, they have class limits and class boundaries, a thing called midpoint, a thing called frequency, a thing called relative frequency, and finally cumulative frequency. So they are doing like anything that you could possibly want to in this big table. But we have to figure out what a class limit is and what a class boundary is. So let me show you, because it's quicker than me going through that whole process all over again. Okay. and the little darlings. Forget these numbers here for a minute. Right?
We started at the wrong number, I think, for the class limits.
I did, or they did? I did. Yeah. So
Yeah,
there's a 20 something in there, and I started at what, 29? What should I have started at?
the 24.
Oh God, yeah. I can't fix that, although I can do this, which is good. Can you pretend I started at the right number? And if I did, I would have got this exact same answers that they got, right? So if I had noticed that there was a 24 there and not a 29, I would have been good to go. Now, class boundaries, start, finish, we've done them. Now we've got the right numbers. Class boundaries, the 24, that guy is 23.5, and the 33 is 33.5. Can you imagine that this is 24 and this is 33? The class boundary is just basically add a 0.5 and take away 0.5. They're trying to, do you know, from the number 15 to 16, there's a kind of grey area in the middle. They're just saying, well, that would be 15.5. So if you take your class limits, right, these two numbers, and you take 0.5 away from this guy, you'll get the lower class boundary. And if you add a 0.5, you get the upper class boundary. Are you comfortable about how these class boundaries are formed then? Once you've got these numbers correct. Oh, by the way, when you're doing your homework question, I would probably fill these ones in and then ask it to tell me if I'm correct, and hopefully it will say you did the first bit wrong and I would fix it, rather than me going through all of this and having to fix everything. Now, we've got a guy called midpoint that we've not talked about. And this first class interval, this first class boundary, has a midpoint at 28.5. How do you get a midpoint for that first row?
Do you add the 2 and then divide by 2?
Yep, you just, now, if you add 24 and 33 together, and then divide the answer by 2, you get 28.5. If you add 23.5 and 33.5 together and then divide them by 2, you also get 28.5. So me being lazy, wouldn't it be easier to use the nice whole numbers? Add the start and finish. And the midpoint gives it away, isn't that the middle number between the start and the finish? So add in half gives you. So that's where they come from. Now, let's look at frequencies. We have got to add up all the numbers between 24 and 33. And that's not fun. So let's see if I can cheat by using salt. Okay, here is my data, right? And I'm going to go into charts and graphs. And I'm going to select the variable, which is percentages. And the class width was 9. And what was the starting? The starting point was 24, wasn't it? That's the one I should have got the first time. So make sure that we use the same class width. That way we'll generate it, and we'll go like this. And there's 5 of them, and there's 20 of them, and there's 19 of them, and there's 4 of them, and there's 1 of them, and allegedly there's 1 of them, provided I've done everything else right. Oh, they got 6. Why did they get 6? What's the smallest number, everybody? Is it 24 or is there something less than 24?
Thought it was 24.
Yeah. Okay, that didn't work the way I thought it was. Well, let's do it the slow way. According to them, there are 6 numbers in this group. So let's see if I can find them. Anything that's 20 something up to 33. So on the top row, there's nobody. On the second row, I've got that guy. So that's 1 so far, including 33. So that's 2. There's that 24, 3. Nobody else. 4, gotcha. 5. You're right, there's 6. That's where the 6 came from. Okay, can't cheat. You have to tweak the WebAssign, but I can still count, right? So there are 6 of them, so I'm happy. And then you could use that guy. Hey, darn it in space. There, what does it do? It goes up 2 hills, drops down. Okay, so try and look at that shape. And the one that looks most like that shape, oh, they all look like that shape. That's annoying. Okay, the first one should be, oh, it's a frequency. What do they want? Draw a histogram. Okay, so they want this guy. That's a relative frequency. That's percentages and stuff. Okay. And move on. Oh, this fella here. I'm getting really too many windows distracting me. Good, the answer's gone again. I want to check something. Okay, then I need to leave. To finish this question off, we have a couple of tables and some values to get, but I need to be in student view to show you them. Right. Right. You remember that table? We've got it all in. Can we pretend for a minute, because I don't have the data, that these are the numbers? Well, 6, 5, 10, 9, and something else to finish with. So 11, 20, 10 again, right? Just making up numbers. Right, altogether there's 20, there's 40 numbers here. If you want the relative frequency, you take 6 and you divide it by the total, which is 40. And you get the answer 0.15. And then you take 5 and divide it by the total, which was 40 numbers, and you get 0.125. And then you 10 gets you 0.25. That 10 also gets you 0.25. And 9 out of 40 gets you 0.225. So that's how you get relative frequency. You take the frequency and divide it by the total number, and I'm just pretending that there's 40 numbers there. Now, to get the cumulative frequency, the first interval, there's 6 numbers. The second one, there's 5 more, so that becomes 11. The next group has 10 more, so that now becomes 21. The next group has 9, so add 9 more to get 30. And the last group had 10, and you got 40. And that's how a cumulative frequency gets created. So if you know the frequencies and they're correct, divide them by the total number, in this case 40, to get the relative frequencies. To get the cumulative frequency, start off with the same first number, and then add 5 to that, add 10 to that, add 9, and finally add 10, and you get this. And down here, we are going to do what's called an OJI curve. It's basically a line graph that you use for our data. So I'll have to write these numbers down so I can use them. So in my case, it's 6, 11, 21, 30, and 40. So going to go here. I think it's that one. And we have 6, 11. Oh, that's not the curve. Okay, which one do I want then? This one? This one? Oh, this one I just did. This one? The next number after 11 was 21. Okay. Double check. That's a dot. That's not me. That's a curve. That's a circle. That's not me. That's that. What does that do? No. Okay. Then I'm going to have to do it the slow way. Start at that number and finish at 21. And start at 21 and finish at 30. There we go. And start at 30 and finish at 40. Right. And I know that's not the right numbers, but if I click on that again, I should be fine. Let me try something just out of curiosity. It might be that I just clicked off it. Why can't I just do, come on, behave. There, there, there. No, I won't do it. Okay, so make that one go away. Well, that's essentially how I do it. Now, do you notice this one here isn't quite matching? So if you click on that, you can see the numbers that I was using. And you can see 11 to 21. And then that says 40.5 and 50.5, which should have been 40. And that should have been 50 there. So you can go in and tweak it if you notice that some of them are just a little bit out. And that's an OJI curve. Looking at our time, we're getting close to the end. So this is our last question. When you do a cumulative frequency table and you do it by a sequence of points joined like that, like sequence of dots, that's basically telling you the cumulative frequency as you start from the smallest and finish with the largest value. Now, this particular one is from the US Census data, and it shows the average annual personal income for each the 50 states. So the data has been rounded to the nearest 1,000. So how would I read that? There. Start there. 32,500, you get to 17. So what that, I would interpret that to mean that 32,500 or less per year, right? 17 of the states in America have that. So that would be what, the poorest 17 states, right, wherever that may be. Now, if you move up to 37.5, do you see there's now 35 states there? That tells me that 35 states in America have 37,500 per year income or less. Now, by the time you get to 47,500, right? So the average in that state that an adult makes is 47,500. 48 of the states have reached there. So doesn't that mean 48 of the states have that number or less? And then if we get to the 50th one, the last one is that. Now, if you know anything about America, which state do you think's probably got the highest? I've got an idea what I think it is. The highest per capita income. What state's the richest? I could be wrong, but this is my thought. What do you think it is?
York,
Say that again, Ali.
New York.
I'm thinking it would be New York, because what I've heard, isn't New York extremely expensive place to live in? So yeah, there are going to be lots of poor people, right, who work in restaurants and don't get great money, but aren't there going to be a whole load of stock exchange and bankers and pop stars that try and tell me how to think, and all sorts of people living there who make buku bucks? So I would guess that. If I didn't do New York, I probably would have done as my second guess California. Now, what I don't know is enough about America to know which is the poorest state. Does anybody want to throw in their 5 cents worth? What kind of
South
state?
Carolina.
South Carolina is a pretty poor place.
I used to live there, so it felt
Yeah.
like it.
Okay, so it might be there. So this type of cumulative frequency is called a no-jive curve. That's what its name, even if it isn't very curved. Now, if you take this data and you do it as a percentage, all they're doing is saying, okay, 17 out of 50 is 34%, right? 48 out of 50 is 98. Isn't this basically telling you the same information, but in terms of what percentage of the states have this income or less? And then it goes on and it just asks us some questions, not that many. How many, or how were the percentage shown in graph 2 computed? Well, didn't you take each number here and divide it by 50 and make it a percentage? So one of those sentences represents that. Now, how many states have a per capita income that's less than 37.5? So if we go here, how many? Isn't that 35 states? So how many have a per capita income? 35 of the states make that or less a year. Now, the next one says, how many states have an average income between these two ranges? Now, that's a little bit trickier, but you can get it from that curve. 42.5 to 52.5. 42.5 is there, right? 44 states. 52.5 is here, 50, right? So how many states between those two values? Right? 44 to 50.
5,
Right. I think it's 6, isn't it?
6.
6, yeah. I'm about to be proved wrong, but I'm going to go 6. Now that you've got me thinking, let's find out. It was 6. But, you know, if you tried 5, you could retry it. Now, what percentage of the states have an average per capita income more than 47.5? So since it's a percentage I want here, right, the second one, and I want it to be bigger than 47.5. So 96% have that number or less. So how many have that number or more? Yeah, just 4. And to finish, yeah, you got that one right. We're almost finished for today. I want to show you some things. There we go. I'll put that into student view so it looks more like what you have. Right. I mentioned at the start of today, and I'm glad I did, that this section here, we didn't get to it. And so don't worry about it. It's due next week. We haven't covered the work. We're going to be doing it on essentially these 3. And there is your online test 1. So here's the first thing. Don't touch that. Don't go near it until you are ready. Because the minute you click on it, that little timer there is going to count. So I'm going to, no, I can't click on it. You'll see the questions. If I did click on that, it would start saying 1 hour, 59 minutes, 1 hour, 58, right? It would count down. And it's not like, well, I'll go in and do half an hour and then tomorrow I'll finish it. The minute you click on it, you must finish the test in that 2 hour period. You can't go back to it. So bear that in mind. What are you allowed to use in your online test? You are allowed to use any written notes that you've got. You can go and look at the ebook and read something over. If you're not sure about it, you can say, oh, I remember doing a homework question like that. If I go back and look at that, it might help me. Those are okay, right? You're allowed to use your calculator. Okay, you're allowed to use salt if it's necessary. Again, okay. What you're not allowed to do is cheat, which is pretty obvious. Cheating is phoning a friend, asking your partner, asking a total stranger in the street, going to a tutoring service, going to an online tutoring service, using a Ouija board. I think I've covered all the obvious ones. Basically, you can't talk to a human being either electronically or in person. My usual way of figuring out am I cheating is if I feel guilty about it. I don't think I should do that. It doesn't feel right. The chances are that's cheating, so don't do it. Unless you're a sociopath, in which case you don't feel guilty about anything. So if you are a sociopath, ask Ali, should I do this? And she'll say, no, don't do it, right? And that way they'll get around that problem. Okay, time to take attendance. While you're writing down your last name, I'm not going to be available this weekend. I'm off to Vegas in 20 minutes from now. We'll be in the car and on our way. I probably won't be much use to you, but I'll try and check my email from time to time. And if I can help you, I will. Otherwise, hopefully you've got enough done, and look up all the resources that you've got, including I have other videos by other people that go over things like histograms that might be of help. Okay, we're out of here. Bye-bye.